Okay, so in a normal semester, then at this point, you might need a review of factoring. Now, we just did this morning, but that's okay. So here we have, it's just standard form with no a value or an a value of 1. So we're looking for two numbers that multiply to 45 and add to negative 14. So 1 and 45, that's not going to work. 2 doesn't work because it's not even. 3 and 15, we're getting closer. 4 is not going to work. 5 and 9. So if we do 5 plus 9, we get positive 14. We want negative. This one, at first glance, sort of looks tricky, but really, we're going to common factor first. To get rid of that, or to make our a value 1, so we're going to divide by 3. But remember, some of you, when you have a common factor, you can't just, get rid of it. You have to write it out front. If you prefer to write 1s in front of the x's, you can do that. You can do these as guess and check if you want. Some of you, especially if you're good with your multiplication tables, might recognize that 4 and 3 is going to be 12. And if this is a negative 1, then if you do negative 4 and positive 3, then that's going to work. But if you're not, just keep making the chart. So we have 1 and 12, not going to get us 1. 2 and 6, not going to get us 1. 4 and 3, if it's positive, then it would get 7. But if we want negative 1, we can do negative 4 and positive 3 gives us negative 1. So this is like 4.4, what we did this morning. So none of them are divisible by a common factor. So choose one of the methods. You're still, no matter what you do, you're still kind of thinking what numbers multiply to, you have to do a times c, 2 and 12, which is 24, and add to negative 11. '24 has lots of factors, but again, maybe you're starting to realize 1 and 24 is not going to work. 2 and 12 gets us close. What's next? 3 and 8. Oh, 3 plus 8, 11. We want negative, so let's try negative 3, negative 8, negative 11. So if you're going to do decomposition, that's where we decompose this middle number, break it apart. So what I'll do, because we need these two numbers anyways, I'll do decomposition first. I'll also write up magic X. So if you prefer magic X, just wait, and I'll show that in a second, okay? So now we need to group factor. Take out the X. That's the only common thing, variable or number here. Over here, now we know we want 2x minus 3, so that can help guide you. 8 and 12, 4 is a factor, you could take that out. We'll take out negative 4, gets us positive 2x, and minus 3. If you are the kind of person who likes to write what you're dividing by, write that in too if you want. But you don't have to. So now our common factor is 2x minus 3, and then x minus 4 is what's left. Because this value here is not 1 anymore. You can do it here, but when you do 45 times 1, it's 45, right? So technically we are doing that here, but you have to do it here. No, this is 4.4, what we did today. Hi, I'm good, yeah. No. Okay, good luck. Okay, so if you are a magic X sort of person, I apologize, I'm going to squish it maybe over here. So magic X is still A times C and B. So 24 and negative 11 add to B. So you still need these two numbers. So you're still sort of thinking the chart. So if you like decomposition, do decomposition. It doesn't really matter. We still need the two numbers. But the weird thing about magic X, you have to divide by the A value. So the A value could be 1,000,000, could be 2, 3, 4, 5. Usually it's not 1,000,000. But here it happens to be 2. So then the bottom goes first, minus 3. Can I put it in like this? What do I have to do? Negative 8 over 2. Yes, you have to reduce, right? And you can, even if you had this fraction, say as an answer, had nothing to do with factoring, you would never leave an answer as negative 8 over 2, right? So the same sort of thing applies here. Negative 4 over 1. So 1x minus 4. Neither of these methods is better than the other in terms of what you should feel about yourself or whatever, the chance of you being successful. What it's going to matter which one you like better, okay? But still, really, you have to think this first. Two numbers that multiply to A times C and add to B. Yes, Erica? Nope. It's never going to say you must use guess and check, never going to say decomposition. No, you pick what you like. Okay, so now this one is wacky, right? There's x cubed, there's y, what's going on? So this, or y cubed, x, this is just a common factor. So you look for the lowest exponent. So we have x and y. And again, when you have a common factor, you can't just ignore it now. You have to put it out front. And then look at what's left. The x's cancel, y cubed and y makes y to the power of 2. The 2 can't go away, x's cancel, y2 minus, or divide by y, cancels one of the y's, and x and y totally cancels, so you get 1. Yes, so the reason is, let's say if you have this, so that's like 1 minus 1, which makes 0. What's anything to the power of 0? Yes. It's like saying, how do I get, when you have x squared, that's like x times x. So now you're saying, I'm not multiplying x by anything. So if I don't want to change my answer, you multiply by 1. Or if you have a million divided by a million, what do you get? 1. So something divided by itself will always get you 1. You can think of it either way. So in this lesson, we're going to do special quadratics, and sometimes students get a little bit arrogant, and they think it's going to be easy, and really it should be easy, but when you put them all together, it can be difficult to see. So we have a special form in 4.5. We're going to have 2 squared terms. The x squared term is going to be a squared number, so like 4x squared, 16x squared, and the c value will be able to be square rooted. 49, 25, 144, 121, okay? So we call these a difference of squares because you're subtracting 2 squared numbers. For grade 10, the squared numbers will be whole, okay? So you don't have to worry about like an improper squared term. You guys are going to do a whole unit in grade 11 on radicals, they're called, okay? Yes. Because I was trying to make it easier. We can do this too. Two numbers that multiply to 1. Yeah. Yes. If I wanted you to do something like this, it would be like this. I wouldn't put x and y. I was trying to make it easier, but Kyle wanted me to do that. Okay, so when you have a square term, like I said, you think when I do these examples, that it's so easy to recognize the squared terms. But first of all, some people, the square root button on your calculator is in a weird spot or whatever. So really make sure that you know how to square root a number. So square terms would be something like 25. You could square root that to get 5. Whatever. 16, 181, whatever you like. If I write this down, square root of 25 is 5. Is that a complete, perfectly correct answer? No. 5 times 5 is 25. What about negative 5 times negative 5? What do you get? positive 25, right? So every single answer to a square root, sometimes you'll see it written like this, plus or minus, plus or minus, plus or minus. When we do the quadratic formula, the next time we come back, we're going to do that. There are plenty of cases in science and chemistry as well, where you have to consider what is the positive answer to the square root and what is the negative answer to the square root, okay? We'll see. You wait for your friend who's on his phone. Okay, so you can have squared terms with variables, like x squared. You could have x to the power 4. You could have something like this, where you would have to square root the number and the x term. You could also, when you have, let's say something like this, right? So what we've been doing, you've been foiling this so far, so we write it out like this. That's what that is. But let's say I want to square root this. So this would be like if we were going to FOIL. So if I want to square root this, what happens to the squared? Yes. So we would have said, like, say you had x squared and you had to solve for x. What's the inverse of squared? Square root, right? You've already kind of done this. Do you have a question, Claire? You would have, yes. Okay, so you can square root a binomial as well. To be honest, so the last example in this note is square rooting or having a squared, that's a binomial. I believe in the textbook, old textbook I mean, there were homework questions that were sort of ruthless. Your textbook's a little bit kinder, okay? So, but we'll still do the example just in case. You can handle it, I have faith. Okay? So is 25 a squared term? Can you square root 25 nicely and get a whole number? Yes. Is 10? Nope. 144x squared. Yes. 12x. 4x cubed. 100y squared. Yes. 2x plus 3 squared. Yes. Okay? So sometimes it's easier to see if you do the FOIL first. So in all of these questions, it almost looks perfectly identical, except here. This is a plus, this is plus, minus. minus, plus, minus, plus, plus, minus. I think I said the first one wrong. It doesn't matter. It just has to be one of them is positive, one binomial, and the other one is negative. And what happens is, so you guys have already seen this because we've already FOILed. So if you FOIL, so first is x squared, second is 4x, the inside negative 4x, negative 4 times positive 4 is negative 16. So when you have one term that's the same as the other term except the sign, then if you have plus 4 and minus 4, what do you get? Pardon? 0, yes. So that means that that b term or the x term totally goes away, okay? So when you collect the like terms, you're going to get 0x. So then it turns into what we call a difference of squares. This is a squared term. Is 16 a squared term? Yes. Now, the annoying part to this is that it's always a difference, always going to be negative. So in here. So when you're thinking about what's the square root, just square root the 16, not negative 16, because your calculator will say error. Okay? So we square root x, what do we get? X. Square root 16, what do we get? Negative 4 and positive 4. So there is always a positive and negative root. Okay, so we're going to do the other one. We have 2x times 2x is 4x squared. So a number out front, no big deal, but it's going to still be a squared. Negative 2x times positive 7 is positive 14x. Negative 7 times 2x is negative 14x. And then you have negative 7 and positive 7, which is negative 49. So again, positive 14x, negative 14x is going to cancel out or become 0, and you're left with 4x squared minus 49. So the square root of 4, 2x, square root of 49, negative 7, positive 7. We can do the same thing down here. Again, what I would do is the same sort of FOIL that we've been doing before. Do the expand the two brackets first and then multiply by 3. So x squared plus 5x minus 5x minus 25. It doesn't matter if you collect the like terms and then distribute the 3 or not. You just have to do more multiplying. Okay? So this is the worst kind, or the most difficult kind of difference of square question, because 3 is not a perfect square, and neither is 75. How do I get to a perfect square? You would have to common factor first. So we're going to do a variety of examples, okay? If you are the kind of person who likes general formulas, that's this one here. Okay, so we have positive mn, negative mn, so we get m squared minus n squared. This is also the official definition. You square root the a term, square root the c term, and you consider the positive and the negative root. So there is never going to be a middle term. There's never going to be a b term when you have a difference of squares. Okay, so sometimes they are very straightforward. So again, what should you look for? No. No BX term, so this looks weird. There's no common factor. So then you're like, oh yes, okay, I'm gonna square root. What's the square root of x? X. What's the square root of 100? 10? Positive 10, negative 10. It doesn't matter, you can put the negative first. Just one has to be positive and one has to be negative. Because you want that B term to cancel out, so plus minus. Okay, so what's the square root of 25? 5. Square root of 64 is 8. I'm going to write the negative first this time. Same thing here, square root of 4 is 2x, square root of x, negative 7, positive 7. So at first glance, can you square root 32 or square root 50? No. So at first you're like, oh, can't be a difference of squares, but there's no bx term. So remember, at the very beginning, what's always first? Yes. Yes, because it's always going to be a squared, then square root 2 is 1. Oh, no, or what you're doing is, yeah. Yes. But that's not grade 10. We're only going to deal with quadratics. So we can, these are even numbers, we could do 2. 50 isn't divisible by 4, so we're just going to divide by 2. And when you common factor, do you want to get nice squared numbers that are able to be square rooted? Yes. So if you pick the wrong common factor, then you kind of know, whoops, I have to go back and try again. So square root of 16 is 4. Square root of x, square root of x squared is x. Square root of 25 is 5. Because you want the middle term to cancel out. So you need a positive term and negative, right? Because anything plus minus will change to 0, as long as it's perfectly equal. So they almost look identical. One's positive, one's negative. Okay, so this is the one that I said was a little bit gnarly, okay? So if we square root this and square root this, then we need the plus and the minus version of it, right? So yes. Well, so this is the first term. I just square rooted it. So here and here. And then you add the second term and subtract the second term. It is weird, okay? Like I said, I don't really think this is in this textbook. So now this question, even though it looks ugly, when you have something that has like terms, you can't just leave it like this, right? So you have to simplify. So you just really have to be careful of your algebra. So here we have 2x plus 3x. What's that? 5x. If you're a color person, so I just collected those. Negative 4y and positive 7y is plus 3y. Oops. The only problem on this side, this negative is going to change these signs. Okay? So it's kind of like minus 3x minus 7y. So you have to think of that first. So 2x and negative 3x is negative 1x. Negative 4y and negative 7y is negative 11. So normally the toughest type of question would be one like this, where you have to do the common factor first. I think this is an example from the old textbook. Pardon? No. Okay, so now you have a choice. So when you are factoring, first of all, you always have to common factor, and then do you get a binomial or a trinomial? So binomial is 2 terms. Trinomial is 3. And the trinomial we've been dealing with is standard form. So we've been talking about standard form since chapter 3, okay? So if you have, this is what we did, this is 4.4, what we did today, where A is not 1, so you can choose decomposition, magic X, or guess and check. When A is 1, that's what we did yesterday. But both of these are pretty similar. You're still trying to make that little chart. Multiply to C, add to B. Just this one, it's AC, because there's a letter or a number out front of the x squared. If you want common, well, I guess common factor was probably. If it is not a difference of squares, then you're done. You can't do anything further if you've common factored, and that's it. A difference of squares would look like this. Okay, so this is 4.5, what we did today. So tonight, I wrote on here work on test review. However, we're going to do 6.1 tomorrow, which is solving equations using factoring. So it's actually, and we've already done factored form where you guys had to figure out what the x value of the vertex was. So 6.1 is actually not that new, okay? So it shouldn't take that long. So really most of tomorrow, and then Friday morning is going to be review for the test. The test will be after lunch on Friday. So if you didn't do any of 4.4 and obviously 4.5, this is your first priority. If you have zero time on Thursday night, like zero, then start the test review. If not, then wait until tomorrow. You can do it during class and then finish it off at night or whatever. Okay?